Hello and welcome back. This time we'll be looking at for loops, while loops, and recursive functions. Now I went ahead and started us off with a little bit of boilerplate code to speed things along. So let's start off by going over that code. We start off by getting the input for the question of factorial of from the user, and convert that input to an integer and set that equal to x. Now the point of our program will be to find the factorial of whatever number the user gives us. We're going to go ahead and do that in three different ways. So the first is via for loop. The second is via while loop. And the third is via recursion. So let's get, then we print out the results of each of those. And then down here I have just studded out the functions. So here's fact4, which takes the input and just returns it back. Same with fact while and fact. And then of course, if dunder name equals dunder main, then we just run our main program. Let's go ahead and clean that up a little bit. There we go. So we'll start with factorial for via a for loop. So to start off, we're going to want to have a temporary return value that we'll be able to use in our for loop to maintain our value. So to remind everyone, the factorial of a number is that number times every preceding number before it. So if we do a for I in, and this is a new function that we haven't talked about before called range, and what it will do is it will create an iterator that goes across a range of numbers. So by default it starts with 0, and if we did x and goes up to but does not include whatever number you give it. So in this case it would go from 0 all the way to x plus 1 because we want to make sure that we include x. But since we are doing the factorial, we want to make sure that we don't include 0, so we start with 1. And then inside of our for loop we simply multiply and set equal to. So what this will do is it's a shorthand for taking the return value and multiplying it by the integer and setting it equal back to itself. But since there's a shorthand, it's much quicker to do it that way. So we'll use 4. So the factorial of 4 would be 4 times 3 times 2 times 1, which would be 24. And sure enough, for loop is equal to 24, and the other two have the default values of the number that we passed into them. So let's go into, actually real quick, let's go over, let's say you wanted to go backwards over this, because it might be easier, at least conceptually, for you to start at x and go up to, or down to rather, 0. Well, you can also in range define a step. So you can say from x to 0 using the step of -1, and that will make it to where it goes in the reverse direction, which of course would be from highest to lowest. And that will give us the exact same. Again, it will not include 0. It will go down to but not include 0 via the step of -1. So let's do the while loop next. So again, we're going to have a return value that we're going to be using throughout our while loop. With a while loop, we also need to make a incrementer. So we're going to count, or a counter is another way of putting that. And so we're going to start our count at 1 because we don't want to include 0. And so we're going to say while I is less than, and in this case we can say less than or equal to x. And so that saves us a little bit from the for loop. But we're going to say that we want to return multiply and set equal to the return by I, and then we have to make sure that we iterate the I, or else we'll get stuck in an infinite loop. So again, same principle as the multiply equal, but it's addition and equal. So I plus 1 equals I. So that should do us for the while loop. Sure enough, 24, 24. So now we get to the fun part, which is recursion. So what makes recursion is, or rather, what makes a function recursive is that it calls itself. And so if we, a shortcut, if you will, to making the factorial would be to have take in a number and then multiply that number by the factorial of the number before it, the number that is one less than it, which is exactly, if you think about it, what we're doing. So we're multiplying 4 by 3 by 2 by 1, but the factorial of 3 would be 3 times 2 times 1. And the factorial of 2 would be 2 times 1. So 3 times the factorial of 2 would be the factorial of 3, and the factorial of 4 would be 4 times the factorial of 3. So if we did this, we would create an infinite loop, which would be very bad. So we have to make sure that we have a breakout or a default case where we check the value of x and have some sort of default return value. And so in this case, we want to check and make sure that x is not less than or equal to 1. And if it is, then we want to return 1. So that way we can handle not only the end case if this is called properly, which would be 1, but we can also handle zeros and negative numbers and basically incorrect values, and we don't ever get infinite loops. So we will try that now. And sure enough, 24, 24, 24. And you notice the recursive code is much simpler than the loops. Now, there are many times that you will find that recursive functions, the code is just simpler. It's a little bit more thought to go into how to create it and making sure that you get the right default cases and don't run into infinite loops and whatnot in edge cases or whatever. But there's also plenty of cases for loops as well, and for loops especially are wonderful for instance, going over an array of values such as we did last time. So real quick, let's refactor real quick so I can show you one more thing. So what we'll do is let's refactor this print statement out into its own function. We want to be able to print facts, and given the fact for, fact while, and the fact, and we want to go and define this, but we're not quite ready to put out the functionality for it. We just want to stub it out for right now. And since this doesn't require a return value to be stubbed out, we can use the keyword pass, and that will make it to where it will simply pass over that function and move on to the next thing. Now this is mainly useful for because you can't just leave this empty, so you need to have something there, and so therefore if you and it's also more readable. So then if we put our print statement in the function, then it will function as it did before, and that's just a good example of refactorization that you can do. And that way, we could put this in a different file and use it for as part of a library or whatever. So I hope that was helpful. If you have any questions or comments, please leave them below. Let me know if there's anything that's unclear or anything that you would like to see a tutorial on. Have a great day.